So good morning one and all. Today we have discussed about the new model, geosynthetics filters, drains and landfills. So already we have discussed in the function of geosynthetic filtration, drainage system, separation. So there are so many functions are there. So already we have discussed and in detail. So we have discussed about the filter, drains and the other parameters which affect the reinforced earth structures. Now the session 1, so we are talking about the filters and drains. What the concept here, the simple concept is there for the drain filters. So there will be a separation here without geotextile, and this is the with geotextile. How the separation will be there, how it will be filter will be there. The role of groundwater flow and good drainage in the stability of pavements, foundations, retaining walls, slopes and waste containment systems is gaining attention from engineers, practitioners and researchers alike. So nowadays, so the stability of the structures will be based on the role of drainage, filter, separations. So it's very important role where the stability of the structure will be. That is why geosynthetics are being increasingly employed either as filters in the form of geotextiles, non-woven, ovens, already we have discussed, in conjunction with granular materials and pipes, or as both filters and drains in the form of geocomposites. So here the geotextile in filtration and drainage applications for the earth dam. So here, so in the earth dam, so geotextile will be provided and this will be drainage layer, and for the trench drain, so here there will be provided the drainage channels, geotextile surrounding this, bank revetment, so we will provide the revetment here for the geotextile here for the drainage and filtration system. And finally here there will be a bank revetment with the concrete block revetment. So this is by stone pitchings. So in the villages, so many lakes we have seen that, so there will be a stone pitching, and here sometimes concrete block revetment will be provided, and below that so they will provide geotextile for the separation and for the filtration. So these are the applications. And here so we can see simply, so the drainage system will be there. It's a porous pipe where the water will be entered right throughout outside the structure. So using the geotextile filter and use the drainage geocomposites. So sometimes it will be made up of geocomposites here, geomembrane, and this is the retaining wall where we have to provide a drainage system, and this black line, the dark black line is a geocomposites or geotextile. So that will be used for the drainage system. Granular sublayer, so filter layers using geotextile. So obviously, so the stone pitching and this will be the soil mass, they will provide the geotextile in between those two. When apply the load, it will not pass and it will not merge and it will not embedded in the soil. So this will be the soft soil and provide the geotextile. So design criteria of filters and drains. Today, the application of geotextile as filters is the most common use of geosynthetics in civil engineering constructions. So it's very famous, geosynthetics will be used. The ability of geotextile to allow sufficient water flow without migration of soil particles is a critical design requirement for filtration and design applications. Design approaches for geotextile filters are based largely on experience and are wholly empirical in nature. Proper geotextile performance is required for long-term serviceability of the structure. So maybe it will be durable structure or stable structure, and serviceability of the structure will be checked. The following functions must be fulfilled during the design life of the application under consideration. Maintain adequate permeability, permittivity to allow flow of water from the soil layer without significant flow impedance so as not to build up excess hydrostatic pore water pressure behind the geosynthetic. So here the in details we have studied the permeability in the next session. So here adequate permeability, maintain the adequate permeability, prevent significant washout of soil particles, that is soil piping, avoid accumulation of soil particles within the geosynthetic structure called clogging, resulting in complete shut-off of water flow, anti-clogging criteria, survive the installation stresses and any other long-term mechanical, biological or chemical degradation impacts for the lifetime of the structure to perform effectively. So it will be survivability and durability criteria. The important steps required in the design, keeping the critical nature and site condition of the application in view, define the stability requirement and design life, determine the particle size distribution curve and the coefficient of permeability of soil sample from the site. So we have to collect all the soil samples, and we have to check the vertical size distribution in the lab. Coefficient of permeability we have to check for that. Then we have to go with the design conditions. Select drainage aggregate if it has to be used along with the geotextile filter. Assess the reduction in pore water pressure or reduction in water table depending on the requirement in a particular applications, and estimate the water flow into and through the drainage system based on hydraulic gradient and the permeability of the soil. Determine the type and dimensions of the drainage system. Determine the geosynthetic requirement considering the permeability criteria, retention criteria, anti-clogging criteria and survivability criteria as discussed above, and then select the proper geosynthetic accordingly. Monitor installation during the construction and observe the drainage system during and after the storm period. So we have to check at the time of storm periods. Thank you one and all. So in the second session we will continue the drains and filters.